Hi, everyone, and welcome to today's topic that is very nice, very trendy, and very challenging. It's enhance AI workflows, automating hyperparameters tuning with Kubernetes and Kubeflow Katib. I am Fabrizio Sgura. I'm the chief engineer at Veritas Automata. I enjoy life in all aspects, like it's written here, and my job is my favorite game. So if you want to share things with me, know something more about Kubeflow and Katib, and also about Kubernetes and what we do, please scan the QR code and get in touch with me. I will be always really happy to hear from you. Today, the agenda that we are going to cover for this topic is based on an introduction because everyone should get familiar with what we are talking about, some hints about hyperparameters, what they are, why they are important for tuning, introduction to this fantastic tool of Kubeflow, the Kubeflow framework that is called Katib, optimization algorithms in Katib, practical implementation running Katib on Kubernetes, and then we will have also a small demo and a conclusion with what we have get from this kind of presentation. So let's go with the current introduction to Katib's role within Kubeflow. Again, Katib is part of the framework of Kubeflow, so it's a specific component that is based to optimize hyperparameters and perform some activities that are very, very crucial for having the models trained correctly and successfully. But let's see that Kubeflow is an open source platform. It was designed to simplify the deployment, monitoring, and management of machine learning models, but it also includes a lot of pipelines. It's able to deliver your model at the edge if it's the case of your workflow, and it's able to support the entire machine learning lifecycle. Today, they are also integrating a lot of new functions related to specific AI, but for the current context, we are just talking about machine learning. And it's just with double quotes because it's an enormous topic. So Katib's role is that we use it for automating the hyperparameter tuning inside this workflow that is machine learning model training. And the advantage of using a specific Katib integration is that there is really no science to get the hyperparameters before training a model. They are in the first part of the workflow, so you need to create these kind of parameters and optimization before going for the model training. At that point, it is very important that not being a science, not having a mathematical formula, you go by recursively testing on something that is the final result. So you will write basically some code that will just be used by Katib to produce some better results on the hyperparameters. And then with those hyperparameters, you will run the effective process to have deep learning, machine learning, the model perfection, and so on. There are a lot of algorithms and things to consider. One is the neural network search, neural architecture search that is part of the neural network for machine learning. And this is a specific feature that is available inside Katib, among others. The integration with Kubernetes is always ensured by scalability, so you can, on demand, assign more resources or reduce if you are using a lot that are not really necessary for the process, and flexibility because it supports various machine learning frameworks, algorithms, and whatever is related to adapt your use case to something effective to work on this first step that is hyperparameters too. The definition and significance of these hyperparameters, as I said earlier, think about the first step that you have to commit to your process to start working on training. So no hyperparameters, everything is random. The model could be training for days and weeks and produce no results at the end. If you have hyperparameters the right way, then it will succeed almost for sure. Here I have in the slide three main points related to the hyperparameters. Think about this learning rate, batch size, and model architecture as three key points to start working on that. But there are several others. If you will look at the hyperparameters list, there are more related to Bayesian mathematical models, to this neural network search, how I want to go to the effective, better training results. Learning rate is one of the most key aspects of these hyperparameters because it's exactly the step size during the gradient descended optimization. So it's how are you able to go fast in a specific process, and its acronym it's LR, and it's the first one that you will set up when you do this process. You will see in the demo that we will work on learning rate and batch size. The batch size will specify the number of training samples utilized in one iteration. Just on this, think that if you utilize too many training samples in a specific iteration for going to learn on a model, you could just have the machine overwhelmed, not producing results. So just stuck on a process. Or if it's so low number of these samples, you could have an inaccurate result. So it's very important to think about these 2 points. And the number of layers and units in a specific neural network search, define the capacity and ability to capture these complex patterns and results for algorithms. So all of this is effectively summarized in the fact that the hyperparameters proper selection can lead to faster convergence to really have the right model trained in a reasonable amount of time, the better and optimized one. Improve the accuracy. You will see that in the demo, we will have some charts that are describing intersection points by curve, and it will be the accuracy that will be the final result and decision to take a specific set of hyperparameters. And obviously, like I said earlier, if you don't do this kind of optimization for hyperparameters, overfitting, underfitting, prolonged training times, but also missing model training completely. Think about this use case and this case that is really missing the model. You will trash a lot of time and your activity will not complete anymore. The overview again is something that is related for this case to the tuning in AI workflows. So here, think about machine learning and AI, they have similarities. The hyperparameter tuning aims to systematically search for optimal set of hyperparameters. The enhancement of the model performance will be the effective result, and you will not have manual intervention. What is this manual intervention related to? Trying. So think about you have learning rates and you will put a 1 manually and you will see the results in a chart. And then you say, okay, I will put 2. In Katib, you can put a starting point and ending point for numbers. In example, let Katib find the right results. It will do it recursively and programmatically, and you don't have to basically put all the number, look at every test, lose an enormous amount of time, and then after that, go to your model train. The challenge for manual testing, you can imagine that one is time consuming, that is one step at a time. And the other one is a trial and error approach that is You don't have a strategy, so you will start from one, going up to five. Then tomorrow you'll get back and say, "Oh, it was it five? Yes, I wrote it." But if you have a lot of these parameters and you write a lot of things, you could start from the wrong point, get errors, not structural strategy. Leave it to Katib. It's the better solution. Automated tuning is the better approach, and the benefits are that you will save time, enhance the model performance to the optimal conditions, because Katib will find for you all the values that are really effective, and your model will be effective at the end of the process. So the challenges that we had in the past before Katib associated to manual hyperparameter tuning were the time, as already stated, um, very, very long time to train models, the trial and error approach, and the scalability issues. And here I would like to put some words on the ability of Katib of being by Kubernetes a tool that you can scale depending on the amount of information and complexity that you really want to process. So this is a feature that in humans you could say, okay, I have a team of 10 people testing the same hyperparameters for a model. Think about the way that they should communicate. You go from learning rate from 1 to 3, I go to from 4 to 5, etc., etc. And this is scaling to humans, something that Katib is really using pods to do that inside Kubernetes. So together, Kubeflow and Katib, they have a consistent role in hyperparameter tuning, because Kubeflow will also facilitate the deployment of all the things that we got from the process of Katib. So it's not just that you train the model and then you have this bundle to do something, but you don't know what is that something. You can keep following with Kubeflow and use that set of hyperparameters to produce the later learning model, effective learning for the model itself. And the Katib's role in automation for these kind of things is that you have this optimization. We talked about it. The neural architecture search is an addition to hyperparameters tuning that will design a scalable artificial neural network to maximize predictive accuracy and performance. And this is invaluable. The benefits for this kind of integration are, again, scalability and flexibility, like we said, in orchestration given by Kubernetes. Think that you are doing this your way. So you will have a specific tool that you invented to do something on top of that, on top of Kubernetes for hyperparameters tuning. And it will be scalable because it will run in Kubernetes, but it will just be a deployment that you manually did. It will not be integrated with what is the whole process that Kubeflow is ensuring you about. So starting from hyperparameters, going to model training, then distributing the model at the edge via pipelines. The scalability that you can have for your own approach is not the same that you can have from Kubeflow and Katib, also if you use Kubernetes for both cases. That's unique by Kubeflow. And flexibility is because you can have a lot of frameworks and optimization algorithms to effectively achieve these results. Here, there are these optimization algorithms. I just took a couple of them because there are many, but the random search and Bayesian optimization are really what you will use in most cases. When you are, in example, trying a model to learn and recognize letters and digits given an image, and you want to find the exact letter, image, whatever, by searching. The random search will be the first thing that in a square box you will use to find gradients. If it's all white and the number is black, in example, or the letter or digit is black, and you want to find the information, by random search, you will search first black or white. If there are gradients, scale of gradients, you will search something that is more dense. So at that point, you will use Bayesian optimization. I found the black, but that black is not really black, it's a light gray. I want to search around that in terms of a matrix of pixel and find the right information extending the model. So this kind of random search that is randomly getting the sample with a combination of hyperparameters. Think about the learning rate. So, how many steps I need to produce this kind of random search? So, how many times will I search from the gradients? And then after that, how many steps I need in Bayesian optimization for going over and find the right shape that I'm searching for to compare to the rest. And Kubernetes integration for this. So the fact that Katib is utilizing Kubernetes to schedule and do a resource allocation to effectively manage the CPU, the memory, the resources that you are using for this process is foundational. And so is the scalability again. You will be able to use more resources just scaling up the resources that Katib is using. So now, exploring these two, random search and Bayesian, I put a couple of things that are the approach. Look, here is for random search, evaluates hyperparameters configuration independently, exploring the search space without prior assumption. So again, the box, the black and white difference, or the light gray versus dark gray, deep dark gray, and so on, you don't have assumption. You go randomly, pam, pam, pam. And it can be in the center, it's most probably, but you will also search for the rest. Think about the O letter or the zero. Search the center, nothing. So it's really not a science to find an information with random search. It's just case. And the use case, just to use a word game, suitable for large search spaces where prior knowledge is limited. You don't know what you have there, but you know that it's a digit, in example. So it's limited to the fact that you are searching in a set and not in something that is not known what will be, like could be an image. An example, recognize in an image that you have a key. That will be a shape, but recognize objects in the image. That will be complicated because you will have the landscape, the background, a lot of parameters and arguments that really randomizing this search will just give you where the gradients are changing. And for Bayesian optimization, again, think about when you shot to a polygon and you try to get the center and you shoot the first with a pistol and you have the hole. Then you look in your binocular and you see that you want to be accurate and you do the second, the third. And the more it's having a resolution that is giving you accuracy, that will be Bayesian. So if I search and I find the dark gray that I'm searching, I will search around that matrix of pixels or map of pixels. For how to use these algorithms based on model complexity, I tried to give you some examples that will simplify the mathematical models if you never used the approach that we are talking about. But think about the random search, when to use. Again, you have computational resources abundant, so a lot of CPU, a lot of memory, you will have the random produced. If you are familiar with the way that we generate math random or hardware random numbers, you will know that it's a real complex science because we want to ensure that it's so random that when the set is enormous, the number will not appear anymore. And if it appears the second time after an attempt, it will be really a special case. This is when you have abundant resources. But when you have restricted resources, the random search is really something that you have immediately to optimize. So you will start generally with random, but you will move out from random as soon as possible. And the consideration here is that it may require a large number evaluation to find optimal settings. For this reason, I talked about the consequence. When I found something, I need to move out to some better approach to find the rest of the information. And the Bayesian optimization of my findings will be ideal for complex models where evaluation are resource intensive and a more directed search is beneficial. But I need to start from somewhere. So random search and then Bayesian, and it involves a learning phase and may be more complex to implement the Bayesian one. But again, once I have the starting point, it's all easier. The case study that we will see also in the demo is based on digits and letters recognition. That is because it's faster. We will have a result in minutes and not days, like in many cases where the image recognition is more accurate and requires more parameters, a lot of colors, um, gradients, and many things like those. So we will not consider in our case study and demo example a complex one. We will use this Cipher 10 dataset that is available publicly since a lot of time. It has been used in TensorFlow a lot. And in the case, we will use convolutional neural network to improve image classification performance based on this dataset. The hyperparameters tuned will be learning rate and optimizer type, batch size, and number of epochs. Again, here there are four names. We talked just about learning rate and batch size, but investigating, you could find that there are several optimizers, and the number of epochs is how many times I will restart from a set of things to perform a similar activity that will be also having a benefit from the previous one. So generally in Katib, the custom resource definition that we have in Kubernetes, you have custom resource definition to define the resources that you want to effectively produce. So think about Katib, its own custom resource definition for producing a result is the experiment. So at the beginning, as the experiment definition will be a YAML file, you will set up the Katib experiment specifying the search space and optimization algorithm. And this will be the first thing that you will declare in the structure of the YAML manifest. Then you will have the execution, kubectl apply, basically. Nothing difficult to understand. You have to previously got installed the Kubeflow Katib manifest, but it will be how it works. Then you will have the monitoring part, that is how Katib will give you the ability to see the results. Generally, it will be in a chart with curves and a lot of consideration, and a final report, or also a report that is constantly being updated with values depending on the current status of the research, and at the end, the analysis. So the accuracy that will be related to that hyperparameter tuning activities. And with those values, you will be able to put every number that you found for your experiment in the real use case for training the model. So just think about that. Experiment, I do that, QCTL apply, results after some time, the numbers that I get, model training. And this is the recap based on The automation benefits, Katib's role, and Kubernetes scalability. We talk about all of these things, but remember and retake as keys the benefits of having automation of something that is not a science like hyperparameter tuning, that is just attempts. You have to try and try and try. And if you do it manually, it will be terrible. If you reduce the manual effort and enhance model performance through systematic exploration of hyperparameter spaces, then you will be Katib because it's doing exactly that specific activity. So let's reduce manual effort. Let's have more systematic approach for getting these models trained with the right parameters. Let's use Katib because it's giving us this kind of unique ability to produce the results with a systematic approach. It's also using the ability of Kubernetes for scaling. So it's not just only automating this hyperparameter tuning, but it's also using the right resources. And here we could talk also about cost. Generally, when you start thinking about hyperparameters tuning with Katib and you reserve a lot of CPU and memory, but you will not need to really achieve that result by scaling so high the resources, think about going gradually from the minimum required, and then you see that it's not enough and you scale a little more, you will save costs. You will take out from your pocket one coin at a time and not an enormous paper to say, hey, I have a lot of resources, let's see how much I should use. You can add them gradually thanks to this scalability, to the ensure that Kubernetes will give you about the real resources that you need for this complicated process. The idea is that you keep exploring because, in example, for hyperparameters, I mentioned two, then four were considered, but there are a lot. There is a list of 20, 30. And in the README of the repo for the demo, you will see that I put a table there just with a comparison of the hyperparameters and what they do and how they are used generally. I haven't included in this digression because I think that to understand deeply each part of the hyperparameters, you need to try one. Try one, then the next one, a use case. It's really important to visualize what they are doing because, again, this is a science that is generally committed to the machine learning, and the machine will do the learning process. It's not really human learning because it's similar by recurring deep learning models, but the machine will be faster, will be schematically taking an approach, it will be optimizing the specific resources. So you need to consider all of this. And deepening your knowledge is the first step to get better understanding on Katib and then later on the whole Kubeflow ecosystem. I would say that during your second challenge here, that is hands-on learning, why not starting really from Katib? Kubeflow is a framework. You will install a lot of components. It will have pipelines, a UI that will get you in a point where you need to learn a lot of things about Kubernetes. With the demo of this presentation and the README file available in the repository, you will just try, get an understanding, see that the results are applicable to the same container that you have been using to produce the hyperparameters, and get a real use case in a matter of minutes. Then it's up to you to go over and have a better hands-on learning on the complexity of the things that you want to discover by machine learning. There is an enormous community in Kubeflow that they are always very prompt and available to solve all the problems and the discussions at different levels. It can be the beginner learning entry point. Generally, there are already tutorials and a lot of information available for that, up to the researcher and people that are trying to integrate something. An example that is coming from TensorFlow, all the research is Python, Jupyter notebooks. You will see that there are a lot of things that if you have been studying machine learning for some time, also in the past, there is a reconnection with the community of Kubeflow because they evolved all of that and they transform that in something that is very flexible, and they have finally a lot of advanced tutorials. And I am a sort of believer that if you take your hands and you put them on a tutorial where you see results from the beginning to the end, also if it's simple for people that are already involved in that, you will learn better how it works. So now we can shift to the demo. It will be based on a kind cluster installation. It is using Ubuntu. Just put your hands on that and let's follow up with the demo. Go into the repository. So first of all, we go to explore the content of the repository. You see here that I have a README file. It's very extensive. I will follow the steps that I have there, but we will not really complete all the steps that are there. Literally, you can do that. The cluster with kind is already up and running. So we will just follow up with what is written here. Here in the kind folder, you have a script that can help you to install kind. It's just a getkind.sh. Follow up with version 0.20, that is the same that I'm using here. When you create a cluster, I called it Kubeflow Katib demo, but obviously you can use the name that you prefer. And you can check if everything goes correctly and get notes. So if we look at my personal result right now, in my terminal, I will be able to see exactly the kind cluster that I have here. You see here that I did a get cluster. I have many, but this one, Kubeflow Katib demo, is present. And when I do a get nodes, I obtain this output with the node that we are using version 127 of Kubernetes. Is a little bit outdated, but it's fine. You can also try the web version 130. I haven't tried with 133, so it could be different. I suggest you to stay on 130 eventually. And then if you find some issues on this repository, just feel free to open an issue and we fix it together, because the idea is to evolve this demo. Also, getting pods, you see that here I already have installed all the Kubeflow suite of tools. And if we come back to the browser that is here, we will see that in my steps, after the get nodes, I have the Katib setup that is just an apply of an inline and online resource. I'm using Katib standalone 0.17. There are many examples also in the Katib Git repository, so I suggest you to go there and search for them. You see here Katib examples. I took inspiration from this for the experiments that we are going to run in our case. But let's see that we already have everything up and running here. When we do the Kubeflow pods inspection, we already saw that in my terminal they are visible. And now it's time to do a port forward and get the results of the browser, exposing the port 8080 of Kubeflow Katib UI, and we will see practically the results of what we are doing here with the stack. So here I am already, I will just expose the port. I will have to copy the right command. So let's copy the right commands and expose the port of Kubeflow. I already have it up and running, so it's here basically. We see that address is already in use. So refreshing the endpoint of Katib is already up and running. I have it up and running in another window. So the result that you see is that in localhost 8080, you will have the Katib interface. You just have to switch to Kubeflow. And you see that here I already have some experiment that I created previously, but one of them I'm going to create literally as we have here from building the first experiments. So if you go, I want to explain you what I did here because I decided to create from scratch a container also that would have been the reason for you to understand all the steps. So if you go in the Docker folder of the same repository, you will find a Docker file. It's very simple. It's starting from Python. It is installing TensorFlow, and it is copying this train.py that I will explain you what it is. It's heavily commented. Let's go to the train.py. Here I am using a script that is very, very similar to the base of the images that are generally used in the official Katib experiments. If we go here, this is a Bayesian optimization with a simple algorithm for the MLP, and this is using the mnist.py, mnist. It's a file that is already present inside this image that they are using officially. I slightly modified this to have you understand how it's done and what we do in a simple, very simple. You see here that it's just more comments than code. Usage of the tuning for hyperparameters and how we research, depending on the approach that we are going to use, the hyperparameters tuning that we need. For our case here, you see that I also left, it's written in the README file, but let's see why this is commented. This one and the last line when there is a save. So here you have the output, and here I commented model save. Once you finish training the hyperparameter, uncommenting this will create a real usage where you can use the hyperparameter for your model and for whatever is needed. So in this case, I'm using the modified National Institute of Standard and Technology NIST dataset that I commented here what it is. It's better if you don't know. It's just 70,000 grayscale images of handwritten digits. So you can imagine that from 0 to 9, you can handwrite digits, and the grayscale with the 28 per 28 sized file will be something that you can use as an input for your model later. But you have to train this model. So explaining how it's conceived to be, in the README file, I decided to describe all the steps. So you can build your first experiment. This is exactly my container image that I also uploaded here in Docker Hub. So you can find it in my Docker Hub. It's free. You can download it and follow up with the experiments that will be available inside that folder that is Docker, Katib Random Search Mist. This is the one that I've been using for creating the experiments, and applying this file, you will be running the experiment itself. What is an experiment? Again, in Katib, having experiments, I have 3 in this folder, and they are heavily documented in the previous README file, so we will see how they are described. Here, this one, that is the one that I created for the train PY that I've been customizing and commenting for you. This one is using my image, and it is doing something, you see, kind experiments. This is for the Kubeflow extension of the API. An experiment is a specific Katib ability to train models and get hyperparameters. You see here that I've been using my image, and with my image, I've been also using two specific hyperparameters, learning rate and batch size, and this will be the matter of our discovery. So if we want to run an experiment inside Kubeflow Katib, we just have to take the YAML file, that manifest file that I had there, and create the experiment from this. So at this point, what I'm supposed to see in the demo is that I will run these commands on top of a command line where I have the repository already mapped. So here in the Docker folder, I have my YAML file. I will ensure that the path is correct. I will have to create, here it's missing a -f. So we do this, and this is already existing because I already have the experiment here, but let's remove it. Why not? It's a demo that is supposed to be live. So we will delete the current one. From here in the front end, where is the front end here? We should be able to see the experiment has been deleted. And now we come back to the terminal here. So let's come back to the terminal. And we create the file. At this point, inside Kubernetes, we could look at the log files of everything, but just let's have a look together at what is the result that is inside our front-end interface for Katib. And you see that here, I already have the experiment loaded, up and running, no succeeded trial yet. This is something that I created to have a result in a matter of minutes, because generally this that I ran 2 months ago, I remember that it took hours. You see here that there is a 23, that is 11 o'clock in the night, and then just after 5 hours it ended. This was a Bayesian optimization using the MLP. This is commented in the README file, so we will just talk about what is MLP and CNN later. But basically, this experiment took 5 hours. This is supposed to take minutes. And you see here that we have 2 successful trials. Running trials are 3 successful trials. We need some time for it to complete. Once it will be completed, that should be almost done, it will have the result of tuning for us, a hyperparameter based on accuracy. Now, I don't remember in the YAML file how many successful trials would have been the acceptance criteria. There are 3 up and running. Once we reach that successful trials number, the magic number for this to be acceptable, we will have the better results on accuracy. And we can take this one because it's already completed. You see that in this case, it was not LR and batch size, but it was LR and momentum. So here I have these 2 trial parameters optimized that are usable for my container image from where I ran this experiment. That is basically the Bayesian simple that you can find in the folder. And using these numbers, you will be able and ready to go with the model already having the right hyperparameters. You see here that in a matter of minutes, really, since I consistently reduced the complexity of a research, this means that probably my accuracy will be good, but I will have to spend some more time to have the model working with the right values and the better results for finding those digits in grayscale. It's acceptable for the experiment because here you can find how much time and the batch size, the values
that were initially researched in a range that was extended. So you see here, we start from a small range, then we extend it, and then we compact it to find the right accuracy that is what we are searching for. This was basically that experiment that is related to my container image created and something that you can follow up in the repository, and following the steps, you will be able to get exactly the same results. Now, the idea is that in our case, in example, we could do another thing while I'm going to explain you all the things. We could run or create, in this case, the other experiment that is here, the CNN, and this will probably not have a completion because it's very complicated, but I will run it and I will explain you what is intended to be. So first we create the experiments. Now we go to the interface of Katib here, just to see that the CNN hyperparameter tuning experiment has been created. Will it fail? Will it succeed? We don't know. We have to leave it up and running. It's also searching for accuracy and not for loss. In this case, it is working, and it will, I know by experience that it will take a lot of time because it's a complicated one. It is using a neural network. So it's not random search like this one that we have been using, and this other one that was based on Bayesian MLP. This is way more complicated for CPU and whatever other thing usage that you want to calculate as resources that you are doing here, I/O and many other factors that could be affecting your Kubernetes. Think that I'm running kind, so it's a process that is running inside Docker. It will be better to have a dedicated bare metal cluster or something that is really powerful in terms of resources to have a great experience on hyperparameter tuning. We leave it here and we come back to the README file to look at what we have here, because it's very important for you to get familiar with hyperparameter generics. Here, I suppose to put the hyperparameter name and some explanation. So here you will find what is learning rate, batch size. We have been using momentum in our case. You see here that I explain in this table. It's written by me, so it's not something that you can generally find on the internet. Maybe it's not that accurate as the Katib documentation in the official sites, but it's a compendium. So you can really get benefit from reading this and have an idea of what is a number of epochs, in example, batch size, why we use optimizers, and so on. Optimizer is used in that one that is running now, and it's taking a lot. So just having the idea of what is a model weight like SGD, ADAM, RMS-prop, you can get familiar with terminologies that generally will not be something that are known by heart. You have to study the theory about that. And here I put the list of my experiments. I am explaining what is MLP and CNN for you to get familiar with the concept and finding all the documentation here. So the additional experiments are really what you can find in the Katib example folders. Here you see there are a lot. If you read the README file, and in example, you are attracted by NAS because you think it's network attack storage, it's not. Let's go to see what it is. Neural architecture search, sorry. So inside of this folder, you will find INAS experiments, DARTS experiments. These are not DARTS, but they are differentiable architecture search algorithm, neural architecture search strategies and experiments. So I suggest you to take a look at the official example folder of Katib, because you will get a lot of benefit as time goes by and you get better and familiar with all the concepts. But coming back to my README, that is really an introductive way of learning things. Here, I explained that MLP is the multi-layer perception, and it's briefly explained here how it works. You input data, think that here I explain each neuron in one layer is connected to every neuron to the next layer. Now that means that there are vertices and they are communicating each other. And generally, when you do this kind of optimization for hyperparameter, you don't really know all of these data. But if you take some time to read that here, you will understand the MLP that is based for the two experiments, the one that was already completed, Bayesian optimization simple, and the other one that was the one that I created, and it took 2 minutes. So maximizing accuracy and maximize loss. What we are running right now is the CNN experiment. It's taking a lot of time, and it's the same as maximizing accuracy. You see here that I'm explaining also some kind of brief concepts on convolutional neural network, that is the CNN that is working. And here I put also some use cases for this because image classification is a little bit different from what is recognized as number. So the convolutional neural network is more complex because it's able to understand more complicated objects, like in example, identifying an animal, cats versus dogs, or object detection, meaning that it's not just motion detection, but it's object detection. It's intended to be something that is understanding what that object is. Glass versus dish, in example. Medical imaging and handwriting recognition. So it's not anymore 0 to 9, but it's recognizing your calligraphy, the way that you write. And here there are some comparisons. So what is best for the MLP or the simple experiments that we were considering at the beginning? It's very good for tabular data. It's generally having input in flattened vector. You see here how is different 2D versus 3D. So you can imagine that for a CNN, an SVG file is something that is vectorial. It's different from what you can have in the input of an MLP. And then parameter sharing, meaning that the MLP is just a single operation for optimization. But in CNN, you can move and filter across different images so you can have a better distribution of that. It's something for a more deep demo when there will be more consciousness and knowledge about how this process is working. So you can take some time to read this table. And then these proposed experiments that are the one that we have been seeing, I'm trying to explain them really in detail because I think it's very important that you have a visualization of what is happening there. For that reason, I chose the library, the data set that is just having 0 to 9 grayscale numbers, because it's something that you can figure out immediately, and it's not really the explanation of recognition of a complex object. That will take more time, more resources, and also more techniques. Remember that in that table of hyperparameters, there are many names, and you should get familiar with whatever. Here we're just using two, LR and momentum. So the learning rate and momentum are here considered in the first experiment that was already done in 5 hours, 5-ish, because it was a little bit less than 5 hours, and I ran it 3 months ago when I created this demo for the first presentation that I did. And now the optimization for this was to reach a specific contention on loss. And here I explain almost everything. You should really get benefit reading these parts and how the experiment work. I did this for the 3. It's almost a model. Here I'm talking about the CNN Bayesian optimization. So this is the file that is now up and running. I think that it's not finishing, right? You can see here we should stop the video and come back in probably 12 hours because it's very complicated, and get a result that sometimes could be also failing because See here, there are 3 running trials and 0 succeeded trials for the moment. Now, here is the explanation of what is really the hyperparameters. What are the hyperparameters that we are searching for? Learning rate, and here is the range that I'm using in the manifest, the batch size, and is the range here too, and the, as I said, optimizer. I put double type because it's decimal, integer because it's batch size, how many batches, and the optimizer is categorical. And here again, the options for an optimizer are written here, the 3 that we can use in this case, but it's an advanced topic that maybe is just something that is introductive for learning and understanding the CNN approach for these kind of things. So again, here I'm describing the iteration that we are doing. What is the random search optimization experiment? Here it's the one that I was creating basically here in the other, this one that was my creation here, and this completed quite fast. And finally, coming back to our terminal and to our Visual Studio codes, we see that in Visual Studio Code in the repository, I have the same README file. You can follow up this README file from the repository, finishing the scroll down in the current repository. I'm going to be here with the scroll down. Yeah. We have the description, and I did a comparison. So at the end of this set of experiments, you can find the main differences between why I chose the specific optimization Bayesian one, why I chose the random search and I optimized it for being fast for the demo, and why the CNN is now up and working. So let's say that we could do one experiment. In this case, it's really an experiment. Instead of pausing the video and having it up and running for 12 hours and then getting back with a result that could be failure or success, it will be success. But why don't you do that? And you comment in the video what is the result, the issues that you found, and whatever you want to underline to me. Remember that here in GitLab, this is a public repository. It's in the QR code that you have been scanning at the beginning, and you just have to create an issue or write to me. Please fork it, watch it, start it. There are some guys that already did it. I presented this to students, and they were interacting with me, writing in a chat. So you can do the same. If you find that is consistently effective for you to learn about hyperparameters, I will be really happy to know. But if you find issues, please feel free to underline them. And saying that, let's go for the conclusion. Thank you for staying here with the demo. I'm just going here, but I know that it will take a lot of time. So here you have to run it on your machine and letting me know what is the result. So I will be very happy to know about that.
Okay, I hope that you enjoyed the demo. And this should be just the starting point for you to go over because it was very simple. It was intended to give you the less abilities possible in a world that requires many. So it should be your starting point or your ending point. You don't want to know any more detail about Katib and Kubeflow because you decide to go to DevOps, system administration, or whatever, it's fine. But at least you had a chance to try how Katib works, how the demo worked, the practical approaches. So I would really like you to scan the QR code and come back to me if you have questions, answers, The demo is a public GitHub repository, so it's just a matter for you to go and clone it, fork it, participate, comment, open issues. I was not able to run that because I am using FreeBSD, whatever you want. Let me know. That will be for me a great pleasure because it means that for you it has been worth. See you next time. Very happy and glad to be with you all.